Doesn't matter. They could be wrong. Okay, let's have a look now. So, just before we start, just something to say about semester 2. I was told, now, okay, just to give you a little bit, a small background. You know, there's a person in charge of the course in Manchester. You know, they write the exam and they tell me what to do for the coursework, like the essay and all that. He's in Manchester. Now, I've been here 10 years, and over that time there's been 4 different people in charge. Do you understand? 4 different, like, leaders. The person last year told me that for semester 2, the final exam is supposed to have more semester 2 in it than semester 1. Leave the fly alone. Just leave it alone. I'm telling you something important here. Yes. I need to check with the new guy, but the old guy said semester 2 exam, the final exam, should have more semester 2 in it than semester 1. So that means these topics we're doing, they carry more importance for the final exam. Now, like I said, I need to check with the new guy because each person is different. But the last guy said, you know, it should be more in the exam. I don't know what the story is in chemistry. Is it? You don't know? Okay. I don't know. Would you say it makes sense?
Yeah. Because we have already passed semester 1.
I guess. He's confident. Okay. First one. If a charge on the particle is double, then what happens to the force?
Double.
So if you multiply the charge by 2, then the force becomes twice as big. If you have twice the charge, you'll have twice the force. Okay, so that's fine. Twice, yeah. Now, a 1 microgram particle of charge, 1 millicoulomb, is attracted towards the center of an electric field. So you have a field here, and it's being pulled in, and it's 10 to the minus 3 coulombs, and 10 to the minus 9 kilograms. Yeah. Okay, and what do I want? The electric field. So E equals F over Q. Do I know the Q? Yeah. So that's 10 to the 3 F, because it's 1 over 10 to the minus 3. Now, do I know F? No. But I know it's MA. And do I know the M?
Yes.
I do. So that's 10 to the 6 A. Now, do I know the A? Well, it's 1 centimeter in 1 second. So UV ATS 0.011 B squared? No. B equals U plus AT? Yeah. A is B minus U over T. Well, the U is 0, and the T is 1, so it's 10 to the 6 times 0.01, which is 10 to the 4. I think it's positive 6.
It's not 6, it's 9.
What are you talking about? Yeah, but the mass is 10 to the oh! Sorry. Yeah. We're brothers like that. Okay, so 10 to the minus 6 times 0.01 minus 8 newtons per coulomb. Okay. I think a lot of people got that. Good, so we go on to the next one? Yeah. If this fly was sent to you, it was sent to you to help you practice your relaxation and your concentration. Think of this, and patience. You go out? Yeah, it'd be funny if you flew back in before you closed the door. There we go. Now the fly has felt you learnt your lesson. and has left us.
Smart.
Very smart, right? Okay, number 3. This one caused difficulty for people. A 2 milligram dust particle falls from one copper plate to another copper plate, and it does this in 10 seconds, and the distance between them is 10 centimeters, and it's 2 milligrams, and it falls. And the charge on it is minus 200 E. I'm not too worried about the minus, because we know which way this direction is. It's going down. If the answer was really small, you know, if I said it fell in like 0.001 seconds, then that means the field is pushing it down, because it made it fall faster. But because it took 10 seconds, then clearly the field is slow in its descent. So when you look at the particle, I know the direction. The force from the field must be this way, and the weight must be this way. Okay? So the total force is mg minus EQ. What did I say the m was? 2 milli. So that's 2 times 10 to the minus 6 kilograms times 9.81 minus, now is the E what I want? Yeah, E times 200, whatever the E was, we'll put that in. The F, do I know the F?
No.
No, but I do know it's equal to MA, and I could know the A because of this. So U is 0, V I don't know, A I don't know, T is 10, S is 0.1. What will give me the A? S equals UT plus a half A T squared, which is 100. So that's 50. Yeah, so that's 1 over 500, is it? 50, yeah. A is 1 over 500. So now I have this formula, 2 times 10 to the minus 6 over 500. I'll make that one a minus, and I'll make this a plus. 2 times 10 to the minus 6 times 9.81, that's equal to E. If I then divide this by 200, what's it, 1.61 times 10 to the minus 19, is that the charge of an electron? Is it?
No.
What's the charge of an electron?
1.602.
Oh yeah,
Negative 19.
minus 19.
Yeah.
Okay, question? What? No, is it? Well, let's see what answer I got. And then on the top, I've got plus pretty big. What? Yeah? Yeah? What do you mean when you use... What are you talking about when you use G? For what? In what formula?
No. Teacher, can you redo with E equal to F over Q using F equal to MA? Yeah.
Well, that's the wrong answer.
E equal to
F equals MA, that's right.
yeah, E equal to F over Q.
Yeah?
Yeah.
And how'd you get the F?
1, 2, 4. Sorry. I get E for 1, 2, 4, A, 4, 3.
Yeah, but how'd you get the F? No. No, F is still MA, but the F is two forces. These two. Well, yeah, because there's two combined together.
So it's MA.
F is always MA.
Yeah.
We haven't changed that. Yeah. And it's wrong to say F equals mg because there's more than just gravity acting on it.
Because we don't know A.
You got the same answer. That was an amazingly stupid coincidence. I can't understand how you would get the same answer.
Well, we get different answer.
Right, you just said the same answer. If you just said F equals mg, 2 times it. So you don't get the same answer. Let's see how much money I've got to bet now here. Let's see. Now, I've got €5 and I've got $20.
Wow.
Yeah. And I have a €2 book voucher here. €2 book voucher. Now let's see. I don't believe you. Let's see.
No, let's try E equals to F over Q.
Yes, let's try.
Yeah.
Now I think this is wrong, so don't write it down. E equals
F over Q.
F over Q. Right.
Equal MA over Q.
Equals MA over Q.
No, let me try this first.
Let him try. Let me see. Okay, go on.
And A is 2 times 10 negative 3. I mean, M is 2 times 10 negative
Yeah.
6. And A is 2 times 10 negative 3.
Oh yeah, no, I don't care about that way. I care about the way she talks about using 9.81.
Oh, okay.
Go on, what did you do? E equals F over Q, yeah? mg over Q equals E. Right, let's see now. How many electrons was there? 200? Is that, we won't worry about that. What's the electron number? There you go. Wow. You didn't bet anything against me. I was willing to put $20 on the table. You didn't match it. You have to match my bet. It does. Anyway. Alright, I'll keep the $20 then. Okay. The fact that this is the same answer is just an accident. It can't be the same answer.
If you use by using the correct A.
No. What he's saying is that the total F is MG minus MA. That is not controlled.
No, it's MG minus EQ.
I'm surprised by this that it's the same. It's is it exactly the same?
Yeah.
Wow. Not exactly the same. I'm very surprised that it is this, because the way you're doing it, it's like you're saying that now, this could happen, but what I think maybe is happening here is that, yeah, I'll tell you what's happening here. So when you're doing it this way, you're basically saying that E equals, yeah, okay, actually, this is actually interesting. Why is the answer nearly the same? It only is nearly the same for this question, and the reason it's nearly the same is because the T is large. So let me explain why you got the same answer. When you said F equals, EQ. Well, basically what you're saying is F equals EQ and F equals mg. Like, essentially that's what you're saying. And these must be equal. EQ equals mg. And that's how you got it. Now, that would actually work if they were the same, which coincidentally in this question they're nearly the same. And the reason I know that they're nearly the same is because it takes the particle so long to fall, it must be that the force provided by the field is equal to roughly the weight. Because if the time was really, really big, imagine the time was 100 seconds, then the downward weight here, mg, would nearly be equal to the upward force here, EQ. And the bigger I make the time, the more closer they must be equal to. And in fact, if the time was infinite, what would have happened? They're the same and it's not moving anymore. You know? So the reason your answer works is because the time is large. Because the time is large means that the force from the field is roughly equal to the weight. So it's not exactly the same, there is still a small difference, but this is the reason why it was remarkably close. This only works because the time is large. If I did this question again, if you did this question again and I said the time is 2 seconds, then you will not get a close answer doing it this way.
Teacher,
Yes?
but I get wrong answer.
What?
These are the ways.
Okay, what's your way then?
E equals to F over Q.
Yeah?
And F equals to MA
Yeah?
over Q. Yeah, that's all.
Fine.
Yeah.
But that again is wrong because
No, I used UVATS to find the A.
okay, so you got the A then.
Yeah.
Okay, but the problem with this method is that this formula here, the E equals F over Q, that's the acceleration or the force caused by a particle in an electric field. But this one has two forces on it. The gravity. Yeah, in other words, you can't use this by itself.
But the A is the resultant A, right? So
Yeah, but it's the result of the electric field and the gravity. This A here, true, it's the result, but it's the result of two forces, whereas this formula here is only for one force.
Okay.
Yeah?
I have the correct answer. No, I mean,
Okay.
yeah, the calculation.
Right, number 4 next in a moment. Did anybody get number 4?
Okay.
Yeah? Number 4 now? Okay, number 4. You have a proton and you have an electron. And what do I tell you? I tell you that the radius is 10 minus 10 meters. I also tell you the electric field strength is 1.4 times 10 minus 10 newtons per coulomb. And what is the time it takes to loop around? I like this question. It's an interesting one. Okay, so firstly, this is circular motion. You know, because it's moving in a circle, F equals ma, which equals mv squared over r. But you know that v equals omega r. So this is m omega squared r squared over r, which is m omega squared r. That's the F. But you also know that the force is caused by the electric field. So you also know that F equals EQ. So therefore, EQ equals m omega squared or. So that means omega is EQ over m or square root. Why do I care about that? Because you know that T equals 2 pi over omega. So that will equal 2 pi root the mass by the radius over the field strength by the charge. Let's see what we get. That's proton. That's neutron. That's electron. What did I say the strength was? 1 point times. So the minus 10s cancel. I think that looks okay. Yeah, you got this? 12.67 microseconds. Do this right. Write this down, please. I make it look too easy. Can you see, Sean?
Mm-hmm.
Yep. Yeah. You miss your flight, friend? He'll come back, don't worry. Yep.
Rest for 1 hour.
Huh? Say again?
Rest for 1 hour.
Rest for 1 hour?
Since we have finished that.
I can continue.
Yeah.
What do you want to do?
Quiz for semester 1. Yeah, let's make it more like a quiz.
What?